All right, so dot plots are going to represent your data using X's or dots and whatever other ingenious symbol anybody wants to come up with. So you can literally use whichever symbol you want, okay? Bunch of hearts, go for it. The quantity of the dots tells you the frequency. So the number of times a value is repeated corresponds to the number of dots above that value. So for example, number 9 is repeated how many times in this dot histogram? 3 times. So if we look at the actual data, wait a minute, is this one? I only see 9 minutes, people. Oh, confused. All right, they're also called line plots. I really don't hear people calling it line plots, but here we go. Advantages, they're really easy to make. They show you every data point. Disadvantages, if you have a lot of data points, that's a lot of dots. Are we clear? And then if you have to count the dots, and it's a lot of dots, then you're gonna be counting for a long time. Clear? So, and you really, fractions, what are you gonna do? Put in half a circle for half a fraction, you know? But what if it's a quarter? What if it's 1/8, you know? So it becomes problematic. Dot plots can have specific shapes. If you can draw like a line down the middle, like this, and we say it's symmetric, okay? In upper level math, we start calling this a normal curve, okay? Normal curve shape. In this case, the mean is approximately equal to the median, okay? So the mean, I need something that can stand out more. The mean and the median are pretty much in the same place, okay? They have the same value when you're symmetric. All right, skewed left. This is the one that if you don't get it right from the get-go, you're always going to be confused. Skewed left goes which way? The tail goes left. The tail end is on the left. The line, the flat line is on the left. Stop with the tapping. The flat line is on the left. Are we clear? Some people call it negative skew. So in this case, you see how most of the data is over here around 32? So we would consider this a tail. It's like it's dragging. And then you have all the data points. Okay. So the median, the mean would be somewhere here. The mean gets dragged by the outliers, right? Because you have to include all those numbers. You have to, and so when you end up dividing those numbers a little, it causes the mean to be smaller. But the median will always be around where most of the data is. Capiche? So we say that the mean is less than or to the left of the median. So you have the mean and you have the median. Okay, this one's on to the left, this one's on the right, this one is smaller, this one is bigger. Because you know the numbers are always going to be in numerical order, clear? Skewed right means that your flat line is on the right, that your tail is on the right. Positive skew. And by this we mean you have most of your data here in the lower part, and then over here is where you get your flat line, your tail. Remember, the median is going to be where most of the data is, clear? And the mean is going to get dragged by the outliers. So the median would be on the left. It's going to be smaller value. The mean is probably going to be more on the right of the median, not necessarily at the end. Are we clear? It'll definitely be bigger. So these are questions that they're going to ask you, and I'm going to ask you as well, okay? How does the mean get dragged by the skewness of the data? All right, and the last type of data is constant or uniform, is evenly spread out, or very close to equally spread out, okay? And they're a type of symmetric distributions. Why? Because the mean is going to be approximately equal to the median as well. All right, just like in symmetric. Okay? You can't see if your eyes are closed, Jaden. You know? Because I'm saying see, and then your eyes are closed. Okay, so remember right here, see? Pretty flat across, okay? All right, any questions on the way data ends up looking like? You sure? Which part? Well, you're gonna have a really hard time then as a student not being able to take notes and listen at the same time. So let's start practicing from now on to make it a little bit easier, okay? It's kind of like when you're exercising, it's really hard in the beginning, but like once you get used to it, you run and breathe at the same time. Whereas before you're like, I'm gonna die, I can't run and breathe at the same time. Are we clear? But then you get to be really good like Moses, and you end up winning the 200 meters, you know? What? It's true. All right, we good? Y'all ready? You sure? Is anybody done? Are we going on? Say something. Good, okay, there we go. Nobody's gonna tell me to go back because you're not done, right? All right. Using your notes from the previous page, identify the type of distribution for A and B. Using your notes from the previous page, identify the type of A and B. So how would you classify A? Yes, because the tail's on the right side. Skewed. You're the only one that's thinking something else. Skewed right. All right, this one. Yes, symmetric. Symmetric with a bell-shaped curve, okay, or the normal curve. All right, now let's practice reading the information. Clear? To calculate the mean requires work. You gotta count dots. You ready to count dots? No. No? Well, too bad. Here you go. What's the total number of dots? Same thing for 1 and 2. It's a different question? Okay. All right, what's the total number of dots? 18? I'm gonna write that down. It's 18, okay? I shouldn't put that. Here we go. Over here, what's the total number of dots? Somebody else confirm? Okay, y'all give me the wrong numbers, watch. All right, over here, total number of dots. Start counting. 16? Okay, good. Whew. All right, now we need to remember, you all remember how to calculate the mean, right? We gotta add up all the data points and then divide by the total number of data points that we have. All right, so at least we know we're gonna be dividing by 18, are we clear? This one will be dividing by 23 and this one will be dividing by 16. but we need the numerator. We need the sum of all the data points. All right. Lord have mercy. Okay, here we go. Where do we have enough space? We don't. So here we go, nice and small. What's 3? You see how 3 happens 2 times? So 3 times 2 plus, you see how 3.5 happens how many times? So 3.5 times 3. I know. 4 happens how many times? 4. Right? Unless y'all want to put 4 plus 4 plus 4 plus 4. Okay, you go ahead and do it then. 4.5 happens how many times? Okay. 5 happens 3 times. And 5.5 happens 2 times. Oh, man. Y'all need to write nice and small because y'all don't have my nice pen. Hey, why didn't you grab everybody? What is this? All right, what is all of that equal to? 76.5? Do I have a confirm on that as well? All right, 76.5. There you go. So your mean is going to be 76.5 divided by 18. How much? 4.25. All right, so we already know the next one is 23 dots. Let's see if we can do this a little bit different. 3 happens 1 time, clear? 3.5 happens 2 times. 4 happens 2 times. Figure it out. 4.5 times 3 times. 5, 4 times. I mean, think of it as scratch work. That's why I'm stacking them to use less space. 5.5 happens how many times? 1, 2, 3, 4, 5, 6 times. And 6 happens how many times? There you go. So now figure out how you're going to put that in the calculator with plus signs in between. How much? 114.5? Everybody? We all agree? Okay. All right, the rest of you use a calculator. Let's go. 114.5. Good enough. Here we go. All right, so 114.5 divided by 23. 20, 40, 60, 80, 100. 4 point something, 5 point something, what is it? 4.97? Okay. See, I was close. Oh, let's knock this out. All right, 3 times 3, 3.5 times 2. 5 times 3. 5.5 times 2. whenever you guys get a chance, hopefully you'll go over it. You all done? So what y'all get? 71? Alright, so 171 divided by 16. 4.23? 43. Wow. Lunchtime. Alright, for the median, the other option I can see is to write out the numbers, but that might be too many numbers to write out, so you're just gonna have to work your way backwards. So for example, the way I do it is I cross them out, one in the front and one in the back, and so that I don't mess up, I kind of do one at a time. Now this one's pretty symmetric. Okay, and what you want to do is you want to end up with one dot or two dots, remember? And so you end up with this. And so to calculate the median, it'll be a 4 plus a 4.5 divided by 2. So Christopher, the bell rang a long time ago and I'm already teaching. All right, so anybody, what is this? Okay. All right, 4.25. Okay. All right, same thing here with the median. But once again, this one's not symmetric, so you're gonna have to be careful when you're going back, okay? So if I cross this one out, I cross out one from here. I cross out one from here. The 4.25 came from me adding these two numbers and dividing by 2. All right, cross out one from here and one from there. So if you do this carefully, you won't mess up. Are we clear? There we go. All right, so you see kind of like where we're going with this? And then I'm gonna cross one here. I'm still crossing off on this row. Cross one here, cross that out. Cross one here, and cross that out. Now you'll notice that we're left with only one. All right, that means this is an odd data set. So that means that the median is equal to 5. Any other commentaries about drag queens or anything like that? Please, because you know I'm recording and this is the one that's going to be posted. So if you're ready to focus, let's go attention. If not, please stop talking, okay? All right. This one is smaller. There's only 16 dots. See if you can find the median, okay? Using the strategy that I showed you. Well, for the ones that were paying attention. I'm not repeating what I said when people weren't paying attention. I'm sorry. All right, so for this one, cross one on the front, cross one out on the back. And you just keep going until you end up with 2 dots or 1 dot. Just don't mess up, okay? See? Cross one out, cross that out. All right, so in this case, we end up with 2 of them. All right, so, I mean, I already know it's going to be 4.5, but if you don't, 4.5 plus 4.5 divided by 2, it should give you a 4.5. Are there any questions on this one? Mode. Mode is the number that happens the most. So in this case, both 4 and 4.5 happen the same amount of times. So your mode is 4 and 4.5. They happen the most and the same amount. For this one, the one that happens the most is 5.5, so there's only one mode. The mode for this one is going to be the 3 and the 5. Anybody have any questions on the mode? Because it looks to me like just about everybody was listening. The range. The range is the largest minus the smallest number. So in this case, the range is going to be the 5.5 subtracted 3. There you go. The range for this one is going to be the largest number subtract the smallest number. The range over here is going to be the largest number subtract the smallest number. Now, when I ask you for the shape of the distribution, I'm asking for one of these 4 terms: symmetric, skewed left, skewed right, or uniform. So now, looking at the first dot plot, what's the shape of the distribution? Symmetric. The second one, what's the shape of the distribution? Huh? Skewed left. Fine. This one, what's the shape of the distribution? Uniform. So given a dot distribution, you should be able to calculate the mean, the median, the mode, the range, and the distribution. Are we clear? We did 3 examples. And they're also recorded, so if you missed some of it because you weren't paying attention, watch the video. All right, this dot diagram gives you the following dot plot represents gold medals won at the Special Olympics. Number of gold medals won. What does this mean? What does this mean right here? What does that mean, none? Be more specific. How many? 2 people got no medals. Are we clear? That's what that means. What does this mean? 4 people got 1 medal. What does this mean? What does that mean? That's not correct what you said. Nobody got 7 medals. Clear? How many got 6 medals? How many people got 9 medals? How many people got 8 medals? Nobody, right? So do you understand how to read the dot plot? Yes or no? Yes or no? Okay, good. Answer questions A, B, C, D. Yes, there are 20 participants in the dot plot. All right, you count the X's. B, how many participants won 10 or more medals? You got to include the 10. It says 10 or more. So that's 2 X's, so that's 2 people. Right? How many participants won less than 4 medals? Less than 4 medals means you don't include the 4. Clear? That is 10, right? Clear? So know when you're including and when you're not including, just like less than and greater than, okay? With an equal sign or no equal sign. Describe the data, describe the data distribution and interpret the meaning with respect to this problem situation. And this situation is number of gold medals. Number of 1 gold medals, okay? Does the data make sense and why? First of all, what type of distribution do we have? It's not uniform. There's nothing in 7, 8, 11, 12, and 13. Where are most of the X's? All right, so most of them are here. And then over here, we have like a little bit trailing, right? Is skewed which way? Look at the pictures in the previous notes and stop making up words, okay? Skewed which way? Skewed right. Okay. All right, this is the tail end over here. All right, so why does this distribution make sense? Why do you have less X's in the larger numbers and more X's in the smaller numbers with respect to this context? Be more specific, then it's harder to do. Like, what's harder to do? Be more specific and say it's harder to achieve or to earn more medals, right? It's probably more likely that somebody will win 1 medal, 2 medals, 3 medals, but not very likely that everybody's going to win 10 gold medals. Clear? That's why the data makes sense. That's why it's being skewed right makes sense. Clear? In this situation, which one is going to be bigger? Less than, greater than, less than, or equal to the mean and the median? Compare. In this situation, the mean and the median, are they equal? Is one bigger than the other one? And if so, which one? Once again, look at your notes. In the previous page where we talked about distributions. Yeah, probably in the previous notes. Look, this is we've only done that much, right? We talked about this. I have it written all over my notes. So now, with this type of distribution, which one is going to be? Are they equal? Is one bigger than the other one? And if so, which one? The median is bigger? The mean is bigger. Right? That's what you guys all have in your notes? Okay. So the mean is bigger? Okay. There we go. All right, histograms. Histograms, I don't like making them, and I don't like, I actually didn't like reading them, but most specifically, I don't like making them, okay? But I don't think we have to make them so much as interpret them. All right, a histogram is a graph that displays the frequency, but it's divided into equal intervals, which are called bins. So in this one, we have 4 bins, okay, or 4 stacks. Think of it like laundry, right? And you're sorting it. Which one goes where? So if your number is between 0 and 3, you go in here. If your number is between 4 and 7, you go in there. Get it? So, let's see. What does this say? Books read over the summer break. Number of students, number of books. So how many students read 0 to 3 books in the summer? 7 students. Clear? Because it goes up to 7. Right? How many students read between 4 to 7 books? 9. You see? That's how we read this. 8 to 11? 12 to 15? 4. Clear? Any questions on how to read histograms? All right, we said that 47 was what, 9? Now this is the interesting one. How many more students How many more students read 4 to 7 books than 12 to 15 books? 5? How did they do this? How did they figure out it was 5? Subtract which numbers? 4 to 7 is 9, right? 9 students? How many students read 12 to 15? How many? 4. 9 minus 4 is? Clear? All right, advantages and disadvantages. Have fun reading. Now, when having a histogram, we can make the bins larger, but we can't make the bins smaller. Clear? Because we don't have enough information of inside the bins. So what do I mean? I could probably join these 2 bins and create one, right? I can make the bin bigger, but I can't make the bin smaller because do I know how many students read 0 books? How many students read 1 book? How many students read 2 books? How many students read 3 books? All I know is that 7 of them read anywhere between 0 and 3 books. Clear? So I can't break the interval to create 2 smaller ones, but I can join 2 bins. Clear? Like you have the whites for the laundry basket, and you have the colors. Well, you can make one bigger bin and just chuck them all in there without sorting, right? But your whites might suffer eventually if you just wash everything together. All right, same shapes, symmetric, same deal, median, mean. They're gonna be about the same and in the same place. Okay. Skewed left, same thing. The median will be where the data is, and the mean will be stretched towards the, oh, not mean, goodness gracious. Erase. Right? The outliers are gonna push your mean smaller. Same thing here. Median will be where the data is, and the mean will be pushed towards the tail. Messing up. Uniform. It's pretty much symmetric, so the median and the mean are gonna be the same. Clear? And that's supposed to be in the middle. I started in the middle, but it ended up somewhere. It's the same information as in the previous slide for the distributions, okay? It's not gonna change. That's just how it happens, okay? How the numbers work out. All right, so why don't we take a few minutes and you guys work on practice questions 1, 2, and 3. Go. All right, describe the distribution of each histogram. A, symmetric, correct. What about the distribution of B? Skewed right. Okay. Now, is the mean less, greater, or equal to the median? When you're symmetric, is the mean less than, greater than, or equal to the median? Are you guys taking notes? Yes. You see they're on top of each other? That means they're pretty much going to be the same value. All right. Mean versus the median. If you're skewed right, what's the relationship? Less than, greater than, or equal to the median? The mean is greater than the median? No. Yes, it is. Oh my gosh. Oh, I'm so sorry. It gets confusing. The mean is going to be over. The mean's going to be here because it gets pulled by the outliers, and the median is always where the data is. And so these are the smaller numbers. Clear? And these are the bigger numbers. And that is why. Did I do it right? That's wrong. Ugh. Give me the right inequality. Because I have them backwards here. Mean is bigger. There we go. Like that. The mean is where the bigger numbers are, so the mean is bigger. There we go. Oof. All right, practice 2. How long does it take the students to get ready? 1,000,000 years? How many students answered the question? Is that the total?
Yeah.
All right, so it's 15 students. How many students take less than 40 minutes to get ready? No. Less than 40 means any number less than 40 does not include 40. Yeah, so it's just these right here, 10. Based on the information given, could you redraw the current histogram with intervals half their current size? No. Because we don't have information. We don't have information about the particulars of each bin. All right, let me explain what I mean by that, okay? How many students took about 20 to 29 minutes to be ready? How many students took about 20 to 29 minutes to get ready? Okay, but do we know how many students took exactly 20 minutes?
No.
Exactly 21 minutes. So there's no way we can break this down into smaller bins because we don't know what would go in each of those smaller sections. Clear? So no, we cannot break it down because we don't have information about the particulars of each bin. All right, number 3. Analyze the histogram of which displays the ACT composite score of several randomly chosen students. All right, what is the shape of the distribution? Huh? Symmetric, right? Stop eating the bags when you're snacking, students. Explain what it means in terms of this situation. Does it make sense that the scores of randomly chosen students would be symmetric? Why? Huh? Why does it make sense that the scores on a national state test would be distributed symmetrically? It doesn't? Why doesn't it make sense? Huh? In this class, are the scores distributed evenly? Are the scores symmetric? Are the scores uniform? Does everybody have the same score? Are the scores symmetric? I don't know. What do you guys think? Is everybody passing? Is everybody failing?
That's why it's symmetric.
So wait, where is it more? Is there more passing or less passing? More passing and then there's less failing, right? So you can either have it so that it's skewed like this or maybe potentially evenly distributed. The fact that these are randomly chosen means that about 50% of the students know the average, right? 25% are the top scores and the lower 25% are the lower scorers. It does make sense. These are randomly chosen students, okay? Clear? Whenever you feel like taking that out of your ear, Christian. It does make sense, and I'm not gonna write it down. How many students had an ACT score of at least 20? 7 or 11? What is this? At least 20. What does at least 20 mean? Can it be 20? Huh? At least, give me at least $20. So can I, if I get $20, I'm good? At least $20. Huh? English, English, English. 20 or more. At least $20 means you're not going to sell anything lower than 20. Okay, you got to give me at least 20 bucks if you want me to help you skip class. Clear? I'm not going to do it for anything less than 20. All right, how many students had an ACT score of at least 20? All right, so here is from 10 to 15, right? This is from 15 to 20. And then 20. Oh, wait, it doesn't repeat. That's why I hate histograms. This one is 10 to 14. This one is 15 to 19. This one is 20 to 24. Because it's starting right here. See, this is 25. So this is 25 to 29. This is 30 to 35. At least 20. How many is that? 9, 6, and 5. So 20 students, right? 9 plus 6 plus 5 equals 20. It just happened to be another 20. Thank you, worksheet. All right, how many students had a score less than 30? So that would be this line this way. These 4 bins. 26, which numbers did we use? 4 plus 7 plus 9 plus 6, correct? Y'all sure that's 26? Hello, can you guys please add for me? You have a calculator. Right, this one is 4, this one is 7, this one is 9, and that one is 6. Add those 4 numbers for me.
26.
It is 26? Okay, yes, I can see it now. All right, how many students had an ACT score of exactly 25? Exactly, we don't know. All right. All right, let's stop here.